In this video, we will be adding brightness and render distance to our settings menu. As we all know, video settings vary between each and every game. Some will have the option to change the brightness and render distance, while others will not. It's up to you to decide on what settings you want for your game. As an example, say you are playing a top-down 2D shooter like Monaco. Render distance wouldn't really make sense since the camera is working on a 2D plane, so you wouldn't need to render things away or towards the camera. Instead, they may include something like a zoom in and out function. That said, we will be mainly focusing on 3D games where render distance is actually relevant. Today, we will be learning how to integrate brightness and render distance into our settings menu using the Unity sliders. So before we begin, we need to fix some problems. When we revert back to our previous resolution or display type, saving happened twice. This is because when we revert and assign a new index to dropdown.value, the change triggers the onValueChanged event for the dropdown itself, calling popup handler, and setting the screen or display again. It's not a huge deal, but to fix it, we'll just add another condition in the popup handler that checks if the popup is currently active. Let's start by making the settings menu a prefab, but before we do that, let's change the hierarchy a bit. Add an empty game object named settings menu and move the settings game object under it. Add the settings component to this new game object and copy over the values from our previous settings component. We'll then delete this old component and create a prefab by dragging and dropping the menu into our asset folder. We'll make a folder that will hold all of our prefabs. Now, in order for us to test our video settings, we'll need an environment. You could just add a bunch of primitive objects, but we will be using an agave plant to further demonstrate the effect of our settings. This plant was made by our own means. We'll also make a cube to act as our player. Afterwards, we need to add the ability to open and close the menu. This means that the settings menu should be off when we first play the game, and the menu should open or close when we hit escape. You can refer to our character controller video if you have any questions about the input system, since we'll be using the same coding logic. Add the script to the player and set the primary key to escape. Now, to open and close the menu, we have to reference the settings menu, but we currently have no way of referencing it without it being a scene reference, which is not recommended. So, we'll begin by making a new script called SOGameObject. Delete the start and update function and surround the class with your namespace. Add the createAssetMenu attribute and assign the menu name as SO/GameObject. Change the inheritance to be a scriptable object rather than monobehavior, and create one public GameObject variable called GameObject. We then create a general script called initializeScriptableObjectGO. Remove the start and update function and surround it with your namespace. Add a public variable accepting a scriptable GameObject and another accepting a GameObject. On awake, we will apply this GameObject to the scriptable object. Now, create the new scriptable object and call it SOGameObjectSettings. We'll add the initializeScriptableObjectGO to the settings menu object. Assign the new scriptable object and the child settings menu to the script, not the parent. Apply it to the prefab if a plus sign appears next to the component image. Next, we will create a menu controller script. We'll create two variables. One will be a public variable, accepting the SOGameObject class, and the other will be a private variable, taking on the player input component. For our start function, we'll find the comp player input component on the game object that this script is attached to, and we'll set the settings menu to be off at this point. For our update function, we'll check if the user has hit escape at any point, and we'll open and close it accordingly. We'll make it so that if the pop-up is up, we'll just invoke the revert button, but keep settings open. Otherwise, we'll just close the settings menu. Lastly, add the component to the player and assign the scriptable object to the script in the inspector, and there you have it, an open and closed menu system. Now we'll start with our brightness setting. There is a lot of discussion as to how to deal with brightness, with some using approaches like changing ambient light intensity and others modifying brightness and gamma by other means. In any case, for us there are two ways to reach our end goal. Either utilize shaders and scripting on your camera to control brightness, or utilize post-processing and control the post-exposure to control brightness. Both methods yield similar results, so we decided to use the post-processing method. I will link the shaders and scripting method in the description below. For post-processing, you'll first need to install the post-processing package. Click on Package Manager, look under the Unity Registry tab, and install the post-processing package. Once done, create a new layer called post-processing. On your camera, add a post-processing layer component with the new layer assigned to it. Make a new game object and attach a post-processing volume component. Set is global as true and create a new profile. Under the post-processor, click Add an effect and choose the effect called Color Grading. There are many options you can play around, but we'll be focusing on post-exposure, EV. Change the game object layer to post-processing and mess around with the post-exposure. This is the setting that will control our brightness. Notice how brightness affects our environment, but it does not affect our UI or canvas. This is due to how Unity handles the rendering order. I'll leave a link to the discussion in the description below. From the discussion, one solution is to change the canvas render mode to screen space camera and render the canvas incredibly close to the camera instead of using screen space overlay. This could introduce some problems since objects in the screen could clip between the camera and canvas. However, this seems to be a workable fix for our problem. Let's make a script to assign our camera to this canvas without a scene reference. We'll call the script initialize canvas camera. In this, we'll declare 3 variables, one for the camera game object, one for the canvas itself, and one for the plane distance offset. To assign the camera to the canvas, we need to access the world camera property and assign it the camera attached to the camera game object. We'll also set the plane distance to match our near option under our camera component with a slight offset. In this case, we'll offset it by 0.2. Open the prefab and add this script to the game object with the canvas component. Assign the canvas to the script. Create a scriptable object for the camera and assign it the script as well. Under our camera, add the initialize game object script and add the camera scriptable object and the camera itself to the component. If everything was done correctly, the brightness should now affect the menu UI. We'll now work on our brightness slider. Open the prefab. Under content, add a game object and under this game object, add a slider. Adjust it to however you wish. We'll make this slider go from 0 to 100 and we'll add another text value to the right of the slider. This will be used as a numerical indicator for our brightness. Now let's make a serialized class for our slider called slider settings. Every slider we use will have several controllable options and assignments. We'll need a slider, a text for our numerical values, a maximum setting value, and a minimum setting value. The max and min setting values are the actual settings we will be changing. These are the values that the user will not see. The values the user will see will be based on the max and min value on the slider itself. As an example, our post exposure will be going from -4 to 1, but the user will see this as 0 to 100. Inside our settings script, we'll add a new header for sliders and add our brightness slider variable. We'll also need another public variable to get our post-processing profile information. Inside the start function, add an onValue changed event to the brightness slider that passes its own value to a function called brightness. Since we want our sliders to go from 0 to 100, we'll need to do some math to get our desired conversions. We will create a function called convertValue that is passed in the slider's minimum value, maximum value, and current value. We will also pass in the serialized class's minimum settings value and maximum settings value. In this function, we will be getting the ratio between our actual and virtual ranges. We then take the current value of the slider and multiply it by this ratio. That will then be subtracted by the minimum virtual value multiplied by the ratio of 2. Lastly, we add the actual minimum value to our total and return the final value. It may be hard to explain how we derive this equation, but try any combination of actual and virtual ranges and it will yield the proper actual value. Once we get the final value, we need to access the post exposure inside our profile and overwrite the float parameter with our result. We'll save the current value, virtual value, into our scriptable object and we'll assign the text number to be the value converted into an integer. Note that our scriptable object does not have a brightness value variable. Inside SOSetting, add a public float called brightness value. Inside settings file, add a public float called brightness and set this value to the value found on our scriptable object. Inside load settings file, account for the brightness value inside the initiate settings function. Now it's up to you if you want to set your default values right inside the script or by using scriptable objects inside the project. We will use scriptable objects. Before we start, we must handle our resolution and display type. Both of these should not be editable inside the inspector since we handle those with default settings using the registry. So, we will create our own attribute called attribute read only. This script simply inherits from property attribute. We'll then create another script called draw attribute read only. We'll inherit from the property drawer and assign an attribute called custom property drawer that is a type of attribute read only. This script will simply disable the properties that the attribute is assigned to. Back in SO settings, we'll add this new attribute to width, height, and display type. Now, the scriptable object has the resolution and display type both disabled. With that, we can now create our default settings scriptable object. Change the brightness value to 80. Inside our settings file script, we will declare a static variable that will take in our default settings scriptable object. We'll then assign the brightness value to be the value of our default scriptable object's brightness. Inside our settings script, we'll add another SO settings scriptable object that will be assigned our default scriptable object and pass that into our load settings file variable within the start function. Lastly, under our load settings function, we will change the brightness slider value to match the one on our scriptable object and call the brightness function. Within the inspector, assign the default settings scriptable object and the post-process profile. Open up the brightness slider and add in our slider and text counter. We'll set the max settings value to be 1 and minimum settings value to be -4. These are the values we selected when testing our brightness. Delete the settings file and test to see if brightness is changing as we move the slider. Ensure that the profile and the scriptable object correctly change their values. With that, brightness is finished. Let's make another slider for the render distance. So basically, render distance controls how far the player renders the game from the camera. This is controlled under our main camera called far clipping plane. We'll be adjusting this for our render distance. Inside our prefab, we will duplicate the brightness game object and rename the parent and all its children to be related to render distance. You can keep the slider at 0 to 100, but you can change this to whatever you wish. The math should still work out. Inside our settings script, we will make another public slider setting variable called renderDistanceSlider. We'll also need a reference to the camera and a private variable to cache or hold our camera variable. We'll create a scriptable object header and move all our scriptable objects under here. Before we add more code, I noticed that the start function is getting kind of messy. We'll just take individual chunks of the code and separate them into different functions. The resolutions will be under a function called initializeBeforeLoad, the load lines will be included inside the load settings function, the index and pop-up will be under initializeAfterLoad, and the button events will be declared under a function called buttonEvents. Under the initializeBeforeLoad function, we'll assign the camera component to the camera and use that to control our render distance. Now, we'll do the same process as with brightness, but with render distance. Since we're repeating a very similar process, we will further condense our code. First, add the button event that will call render distance to the slider. We will create a function called sliderConversion that will return a float and accept a slider setting variable and a float variable. We will move our conversion calculation over to this function and change all the variables to match our passed-in slider setting variable. We will also handle changing the number text for each slider here too. We will then return the converted value. Inside our brightness, we will call this slider conversion function and pass in the appropriate variables. We'll then interpret the return value and use it to change our post exposure. We'll also remove the text assignment since slider conversion will handle that. Our render distance function will look very similar to the brightness function, but in this case will affect the camera render distance instead. Now, same as before, we'll need to add the render distance variable to our SO settings, load settings, and settings file now, so please do that. Lastly, add the render distance code to load settings. It should be similar to how we did brightness. Back in our prefab, we'll add the camera scriptable object and set the values for our slider in our settings script. It is up to you on how far you want to render your game. For this project, we will make the far clipping plane have a maximum of 1500 and a minimum of 750. Now, under our default scriptable object, we want to set the default to an actual value of about 1000. The conversion tells me that 1000 is equivalent to about 33 on the slider, so we'll set it to 33. Now we can test this. Delete the settings file and start up the game. The default settings should be applied to the scriptable object and therefore the game itself. Try changing things without saving. It should revert back to what it was on the next startup. Any problems with the render distance? Test to see if the values of the scriptable object is correct. How about after build? Make sure you put the drawer script inside a folder called editor before you try to build. Is it all working fine? If everything is good, then brightness and render distance is complete. Well, I hope you liked this video. We're on our way to finish our video settings. In our next video, we'll be looking inside our project settings and managing a number of quality options. This includes vertical sync, anti-aliasing, shadows, and texture quality. We'll also deal with presets and choose what option would be good at each preset level. Thanks for listening, and I'll see you next time.